Now that we have our V1 release, let's specify in our module the changes that we're going to do. So right now we're just creating a game and making the moves, but the moves are just plain text. And we want this make move to have here a hashed move. So move actually is going to be the SHA-256. That's a hash commonly used. It's going to be the SHA-256 of the move. That can be obviously rock, paper, and scissors. And assault. That's going to be a random string. So only the people that has this assault will know what the move is. And this should be done off chain, so nobody has a record on chain of what the assault is. Only the player that submits the move should have this knowledge. And then we'll have a message reveal move where we are going to specify who's the player. That's going to be the signer, the game index as well, to reveal the move for a specific game. And then we're going to have the revealed move. And this revealed move is just going to be plain text. It's going to be a string. One of these. This actually is going to be a hash. So we can specify here string. It's actually a hash. And then we'll also have to add the salt. So we can check in this message reveal move, we can apply the hash. The way we will validate here, it's going to be, we're going to get the player's move, the hashed move, and then we're going to get the reveal move, and we're going to apply something like this, the same that the user submitted here. That is going to be the revealed move plus the salt. So we'll make this check. And if this is valid, then we can update to the corresponding move the revealed one. In this way, we are implementing a commit and reveal protocol. Quite simple in this case. Additionally to this message reveal move, we're going to add a new event. That's going to be the event reveal move. It's going to be similar to the make move one, but we're going to broadcast here emit the reveal move. This is going to be now a hash. It wouldn't say much, but just saying that there was a move that a player submitted, but no idea which move it is. And this revealed move, revealed move, is going to be one of the valid choices: rock, paper, and scissors. Another cool feature that we are going to add to our module is an expiration time for the games to avoid spamming our chain. For example, if a user creates a lot of games and nobody plays them, it will have like a time to live, and after that time to live, the game will be cancelled. For that, we're going to add a param called TTL, time to live. That's going to be UN64. This is actually going to be the blocks time to live, right? Like the count of blocks, the count of blocks of life of a game. For example, if the game is created in height 10 and the TTL is 10, then the expiration would be height 20. Count life of a game in blocks. Count. That's a better name. Description. And then also to our game, we'll add an expiration height. That will be uint64. It's gonna be negative expiration height. So yeah, this would be a cool feature of it, and we'll see how we can implement this in our chain. The first step to implement these changes is in the proto files. So if we go to our rps.proto, we'll have params here, and we'll define uint64 to be TTL. It's going to be just one param for our module, and then we should add here a new field that's going to be an int64, uint64 to be expiration height. This is going to be number 9. And then in transactions, we have to add our new message. It's going to be the reveal move. So it's going to be similar to this one, but it's going to be reveal. Reveal move. Submit revealed move, and this is going to be submit hashed move to specify game. And we're going to use a message reveal move that will define in a few seconds. Reveal move response. And this is going to be make move and reveal move, something similar like this. Then we'll have the result. Reveal. And here is going to be revealed move, and the salt is going to be a string as well. String salt field number 4, and the message reveal move response type is defined here. And that's it for the protos. The queries are going to remain the same for now. Reveal move response. It's not liking something. Maybe I'm have a typo. Reveal. No reveal. Now everything looks fine. We can run the protogen again. First we can run all the. Remember, I have to use this flag, but that's a specific problem of mine. Probably you will not need to use this. But let's make proto all. This will format, will lint the proto files and generate the updated files. In my case, I have to change the ownership to that was generated as root. Again, if you didn't have to use the use0 flag, you don't need to perform this step. It's just an issue with permissions I'm having at the moment. Everything in this folder is going to be change on and sudo. And that will do. And if we check now in our types, we should have these new parameters and this new. Here we have the new TTL, and the new transaction type, make move, and the reveal. We have it here. So everything is fine. We generate our product files. Now we have to implement the corresponding logic in the message server. We go to the message server.go, and you will see that we are having now this warning because we are not implementing the new reveal move. That's expected because we regenerated our products, and our message server now includes the reveal move. So for now, we'll add it down here in the under the make move. We'll have the reveal move function ms message server, and this is going to be types, and types. For now, we'll leave it empty, but we'll work on this later to do. And then for our create game, now we have to add the expiration height field that we included in these latest changes. And to get the expiration, we should get the SDK context from here, and we can get what we'll need is the SDK current block height, and the expiration is going to be the block height plus the TTL, right? So let's get the TTL. It's in our params, so we can get those params using the get params and skeeper and params get context. If there's an error here, we'll return the error. For the nil, return nil and the error. But if we get the params, we have now the TTL from the params.ttl, that it's at uint64, and we have to convert it to uint. In this case, the block height, because we are going to save here the expiration height is uint64, so we should convert this to uint64, and this is our expiration. We can add it here. Actually, we can just add this directly. It will work the same. Let's format this. Now we have our expiration height. What we should define is a default for the params for the TTL. So to do that, in our types, we have the params. And remember that we had these set default params. And we can add here a constant to be default TTL. In this case, I don't know, 20. Anyways, it can be changed via governance proposal. And the default values here, it's TTL, default TTL. And in the validation, we can add a check that TTL has to be greater than 0. Params TTL equals 0 will return an error of invalid TTL, valid TTL, but 13 TTL should be greater than 0. invalid. TTL, everything's fine. Format this. And now we'll have to edit the make move and the reveal move to add the corresponding logic. This one I will leave it to you, and afterwards we'll get together and see what changes I applied. But basically here in the make move, instead of checking a valid move, you have to check if it is a hash. And then these checks are the same. But you should also here remove this logic about calculating the round winner, because this is going to be calculated during the reveal stage, and updating the results. Look into this as well. But yeah, I'll leave it to you, and here pause the video, and afterwards we'll get the changes that I did. Here I added the changes. Here's the make move edited, so you will see that I here replace with our game ended to check the status. So if it is ended, it will return an error. And then I also added some useful functions in our game type to add player move and reveal a player move. We go to our types, game.go, you will see that I added here a few functions to get the last player moves and what's the player type based on the rules, and also to check if a round is revealed, fully revealed. And then also we have this add player move that uses these functions that I mentioned previously, the player type, to validate the players in the game. And then we check that it is a valid hash, the move submitted in the message. And then we get the different player moves and check if it is a valid move. The previous one, checking that the previous one was revealed. Player cannot submit a new hashed move if it hasn't revealed previously the previous move. So this is what this check is doing. And then we check that if the previous move was revealed, but the opponent's move was not revealed, then you cannot submit a new commitment. We'll have to wait for a round to finalize before submitting a new commitment. And then we have this can make move check again, and we update the stored player A moves and B moves accordingly. And then we do a validation and set the state. And after setting the state and making sure everything went through, we emit a make move event. This one, if you haven't added yet, it's inside events.proto. It's pretty much the same as the make move, only that we have this reveal mode field. And then make sure to generate again the protos to get this corresponding Golang type. Then we have the reveal move, where we check again if the game exists. If the game still it's in progress or waiting, and then we will call this reveal player move. That's a function that we define here in the game.go under the types directory. That will check if it is a valid move. This is just a plain text revealed move. And then we're going to do some other sanity checks that you can only reveal if both players submitted the commitment. And then we check the commitments for each of the players, if it is a valid hash, and check if the revealed move corresponds to the hashed value that was submitted previously. This is move reveal. It's going to calculate the hash from the move and the salt that it's provided in the message. Our message reveal move, we have the reveal move and the salt. So I added this utils that go under the types. to manage the hashes, either to check if it's a valid SHA-256 hash, and to calculate the hash when the message with the move and the salt is provided and it's validated against the commitment. Make sure also that you added the corresponding interface here in our codec, the reveal move, to register this message type, and also in the auto CLI the RPC method reveal move, so we can use the CLI with this. So let's now compile this. And make init to initialize from a new chain with the latest changes, and then we can run the rpsd start, and now we should see that we have the transaction or revealing move rps help. Let's see if we have the reveal move. All looks good. So let's create a game. RPSC transaction RPS. Let's first get the list of keys to get Bob's address. We are going to create a game against Bob. 3 rounds from Alice. Yes, we're going to broadcast and sign that transaction. Let's query the game. If the game was created alright. Now I can submit transaction, make move to game 1, and our hashed move, we can calculate it with this page that calculates the SHA-256 hash. So in our case, we're going to say rock option, and our salt, that should be a random string. Let's just use AAA. So we get this is the corresponding hash, and we're going to submit this hash from Alice. Oh, I'm missing the RPS here, RPS module. We're going to broadcast this transaction. Let's check again our game if it was updated with our hashed move. Query RPS game 1. We can see that the first player submitted a hash already, and now in order to reveal this move, we'll have to wait for player B, that it's Bob. So let's submit the same move for Bob. Broadcast that. Query if we get both. Now both of them have the hash moves here and here. It's the same. Obviously this will never happen ideally. And now we can perform the reveal move, and we provide here, let's see what's the order, but we should provide the reveal move and the salt. So game index 1, reveal move rock, AAA, it's our salt from Alice, and we're going to sign and broadcast transaction. And now the Alice's move should be revealed. Game 1, and you can see that Alice's move is revealed to be rock. So that's working. We can check also the transaction here if it emitted the reveal event. And here you can see the event reveal move with the reveal move here, rock, and the player and the game number. Everything is working as expected. Later on we'll write for test. Obviously the ideal is to write test as long as you add code. but we'll cover this in the next module. But for now, this is good to know that it's working as we expect. The other feature that we need to implement now is the expiration of the games. Remember that we added in our game type, we added here expiration height. Let's see how we can enforce this to when the expiration height is reached, the game expires and nobody else can submit any move to that game.